Yesterday we were discuss about power diode. Today we'll discuss about power transistor. ठीक है. স্ক্ৰীনখন দেখা পাইছে নাই বাবু?
Yes, sir.
Power transistor. Power transistor. What is transistor basically? Transistor is a three-terminal electronic device. First thing. Next is what? Why it is called transistor? Transfer of resistor, right? From low to high. Transfer of resistor. Transistor. And this power transistor basically the three-terminal device which is designed specifically to control high current and voltage setting, and handling large number of power level in a device or a circuit is the power transistor. And classification of power transistor include the following. Same like this one, same like the normal transistors, bipolar junction transistor, MOSFET, that is FET, it is a type of FET, MOSFET, then static induction transistor, and then insulated gate bipolar transistor, IGBTs. Junction transistor which is capable of handling two polarities. Someone is joining or someone is asking for permission. That's it. Okay, somebody is joining. And capable of handling two polarities. Basically, by BJT means bipolar junction. Why it is called bipolar? It has two charge carriers. Means two charge carriers are responsible for conduction of current through the transistor, that is holes and electrons. So it is called bipolar, right? It can be used as a switch or as an amplifier, and also known as the current control device. Yeah, that is by BJTs are basically a current control device. Whereas FET are field effect transistors are what? These
Voltage
are the
control.
voltage control device. Can anybody say why it is called voltage control device?
Sir, তাহাঁতি তিনিটা থাকে নহয় গেট সোর্স ড্রেন মাজত শিফট কৰি এটা ইলেক্ট্ৰনিক সুইচৰ নিচিনা কাম কৰে এইভাবে
No, this is something different thing. This is kind of use. I am asking why it is called voltage control. Because these
Uh,
current following
current
through,
in the
yeah.
current in the drain is controlled by the voltage actually.
For which voltage?
Second, huh?
Which voltage control? That is fine. Voltage you are applying gate source and also drain source. Which voltage will control your current following through the channels?
Gate circuit.
Yeah, gate voltage. Yeah, this is basically for BJ. This FET. FET basically means current following through the FET is depends on what the voltage applied at the gate. Okay, means can be controlled by applying the voltage at the gate. Whereas in case of BJT, that current following through the transistor can be controlled using the by changing the current base current. Okay, right? So it is called current control device, whereas another is called voltage control device. And for power, what some characteristics of power BJT is are not is are it has large size, so the maximum current it has a larger size, so the maximum current can follow through it. Size is higher, and then breakdown voltage is high. It has higher current carrying and high power handling capacity. It has higher onset voltage drop and on-state voltage drop and high power applications. These are the characteristics of power transistor, power BJT. Okay. Another is this MOSFET. This is if you are talking about the MOSFET things, MOSFET it is a subclass of the this is a subclass of FET, and this is same like this three terminal devices, and as the function depends on the width of the channel, right? In MOSFET, depending upon the channel width, this current is being also controlled, and it is the that is if the channel width is wide, it works efficiently following are the characteristics of of a MOSFET. Power MOSFET, it is also known as voltage controller, and no input current is needed. A high input impedance. Input impedance is very high for MOSFET, right? Can anybody say why it is called no input current is needed? What does it mean for this MOSFET? Ajay?
Yes, sir.
Hmm. এইটো কাৰেণ্ট এইটো মছফেটত কৈছে যে ইনপুট কাৰেণ্ট নাই বুলি কৈছে দৰকাৰ নহয় বুলি কৈছে ন' ইনপুট কাৰেণ্ট নিদিয়ে কিয় ইনপুট কাৰেণ্ট নহওঁকে কেনেকে হাউ উইল টু ইনিচিয়েট দিছ থিংছ see what is the MOSFET structure. This gate terminal is separated by an insulating layer, that is silicon dioxide, right? So if you are applying a voltage at the gate, the silicon dioxide will not allow the current to flow into the channel region of this MOSFET, right? But because of this method of induction, some charge accumulation is there in the channel width, for which due to which the channel width is increase or decrease depending upon the operation mode, either enhancement or depletion mode, depending upon the mode how its operation, right? So you are not applying any current at this input current, you are applying some voltage to induce some current, some charge particle, induce charge carriers or charge particles in the channel length so that channel width can be increased or decreased depending upon its operation, right? বুজি পাইছা নাই কথাটো কি?
Yes, sir.
Okay. Next is this one, third one, the static induction transistor. Static induction transistor is somewhat looking like this. Its construction is somewhat like this. Yeah. See how it is a device that has three terminals with a high power and frequency, which is vertically oriented. The main advantage of this static induction transistor is that higher voltage breakdown in comparison with the FET, that is field effect transistor. The following are the characteristics of this transistor. Static induction transistor, that is the length of the channel is short. Here the channel length is short, then noise is less, turn on and off is few seconds, means this is somewhat faster, and terminal resistance is low. Why this terminal resistance are low? Because channel length is short here. Next, let's not discuss with the IGBT and all because these things are same like this insulated gate bipolar junction transistor. We are now we'll discuss this structure of this power transistor, how it is look like. But this, if you see this symbol, there is no difference between power transistor and normal transistor. Symbols are same. Pancha BJT is a vertically oriented device having a large area of cross section with alternate P and N type layer and connected together. It can be designed using PNP or NPN transistor. Okay, but they are vertically designed so that the cross section is large. Next is structure power transistor, that is the following the construction shows as PNP and will show this construction there in the next slide. This is the construction of a power transistor. See the following construction shows the P and that also and PNP transistor, which consists of the three terminals, emitter, base, and collector. The emitter terminals is connected to a highly doped N-type layer. First is highly doped N-type layer, below which a moderately doped P layer of 10 to the power 16 per centimeter cube concentration is present, and a lightly doped N layer of 10 to centimeter cube. This is per centimeter cube. Okay, so concentration, which is also named as collector diffusion, where the collector diffusion decides the breakover voltage of the device at the bottom. It has an N plus layer, that is means highly doped N type layer, which is highly doped N type layer of 10 to the power 19 centimeter per centimeter cube concentration, where the collector is eats away from the for the user interface. See, this is how things are. This is the collector region. This is the base. See, emitter is highly doped. Then on top, and then P type is there. Okay. This is the base region is this one. This is the collector, and this is the base region, because this is lightly doped base, and then some and it is actually these are basically made built on a highly doped n plus semiconductor layer, means highly doped n type semiconductor layer. All these layers are made of. Then operation of a power transistor, how it will operate. Power transistor BJT, basically BJT works in 4 region of operation. They are cutoff region, active region, quasi-saturation, saturation region. Basically power transistor working these 4: cutoff region, active region, quasi-saturation region, and hard saturation region. The power transistor is said to be in a cutoff mode if the NPN power transistor is connected in reverse bias. See, okay, means where if you connect both the junction, that is, if you connect this transistor so that both the junctions are in reverse bias, then you can say someone is joining. Okay. Then you can say this. Then this transistor is in cutoff region. Okay. Then there is a two cases maybe. One is case one. The base terminal of the transistor is connected to negative. See, NPN transistor, there's transistor. If you connect the base terminal in a negative polarity, then obviously P is connected to negative. That means an emitter terminal of the transistor connected to positive, and NPN transistor is emitter is connected to positive. That means you are connecting this both the junction into a reverse bias condition. The collector terminal of the transistor case 2 is connected to the negative, and collector is also this negative, right? Means negative, and base terminal of is connected to the positive. That is base emitter and collector emitter is reverse bias. Is in reverse bias. See, the The collector terminal of the transistor is connected to the negative. Collector terminal is connected to the negative, and the base terminal is connected to the positive. That is, the base emitter and collector emitter is reverse bias. See, this is if this is it will happen how? How it will happen? Collector terminal of the transistor is connected to the negative, and base terminal of the transistor the positive. That is, the base emitter, the collector emitter. Okay, collector emitter is reverse bias. Base emitter junction is reverse bias by connecting this, and if you connect like this, then collector emitter bias the junction will be reverse bias, and there will be no flow of output current to the base of the transistor, where this is IBE, means base emitter current. Okay, base current is 0, and also there will be no output current following through the collector to emitter, since IC or IB are 0. Means IC means collector current, IB base current, which indicates that transistor is in cutoff state. That is a cutoff region, but a small fraction of leakage current follows through the transistor from the collector to emitter. That is called ICEO. That is, some leakage current is follows through because due to the minority charge carrier, and this is that current is called ICEO. You have already been studied. You have studied already. Then the transistor is said to be inactive. No, this is there should be a gap. Okay, inactive state only when the base emitter region is forward bias and the collector emitter region is reverse bias. This is how this normal transistor is working, right? Always input that the junction is when the to make the transistor working, you need to make the base emitter junction forward bias and collector base junction reverse bias, right? And when you are connect bias the transistor like this way, then then this working condition is called this uh, active state. Hence, there will be a flow of current IB, that is I base current in the base of the transistor, and flow of a current IC, that is collector current, through the collector to emitter of the transistor. When IB increases, the IC also increases. Obvious কথা. IB increase হলে IC increase হ'ব, base current increase হলে collector current increase হ'ব. That's all. Then a transistor is said to be in a quasi-saturation state if the base emitter and collector base are connected in forward bias. Okay. যদি দুইটা যদি ট্ৰানজিস্টৰ ট্ৰানজিস্টৰ নহয়, দুইটা যদি জাংচন আমি ফৰৱাৰ্ড বায়াস কৰি কানেক্ট কৰো, তেতিয়াহ'লে then it is called the quasi saturation state. Resistor is said to be in hard saturation if the base emitter and collector emitters are connected in bias. Base emitter and collector base. Same thing, hard saturation, and this is quasi saturation if the base emitter and collector are connected in forward bias and connected in forward bias. But here, in this case, this hard saturation, this voltage is very high area. That is, so it is called hard saturation. This is quasi saturation and hard saturation. Both the junctions are need to be forward bias. So far is the working, how they are working, and we'll discuss its VI characteristics, IB characteristics, or VI characteristics in the next class. Any doubt so far? কিবা ডাউট আছে পাৰ্থ?
নাই ছাৰ।
লৈ আহো মেইন কথাটো। তহঁতৰ পৰীক্ষাটো হেৰি কৰি দিলে, কেনচেল কৰিলে, 5th চেমিষ্টাৰ বাকী থকা পৰীক্ষাটো।
Yes, sir.
এতিয়া that paper was scoring paper, I think. Computer programming to সবে জানিছিল, it was a scoring paper. So, and that and marking will be depends on your 6th semester performance. এই চবতকে ডাঙৰ কথাটো হ'ল এইটো, হে। চেঞ্চৰ ওপৰত তহঁতৰ মাৰ্কিংখন পেপাৰ থাকি গ'ল।
স্যাৰ চাব গ'লে আমাৰ কাৰণে বেয়াই হ'ল।
এইটোতো বেয়া হ'ল, গতিকে ইউ পিপল নিড টু বি ভেৰি চিৰিয়াছ।
এতিয়া মাৰ্কটো আমাৰ হাতত নাই।
That is why you people need to be very serious so that you get good marks in 6th semester. ঠিক আছে, 6th semester মানে ভাল marks পাব লাগিব, and at the same time I got the information your 6th semester will marks will be of 50%, not 50% মানে এনেকুৱা হ'ব there will be 100% means 100 marks question paper. Attempt 50 marks of them. ঠিক আছে, option will be you will get
মানে
lots of
100
option
মার্কের
there.
পেপারের মধ্যে
So মই যিমান দূৰ গম পাইছো মানে ইনফৰমেশ্যন পাইছো, ঠিক আছে। So this is
অনলাইন হ'ব
one
নেকি?
plus নহয় নহয় অনলাইন নহয় অফলাইনে হ'ব।
স্যাৰ কেতিয়ালৈকে হ'ব মানে এনে কোনটো মান্থ
কোনটো মাহলৈকে হ'ব এতিয়ালৈকে কনফাৰ্ম কৰা নাই। তাৰমানে 50% কৰিব যদি এটা কথা হ'ব পাৰে, মানে 50% যদি কৰে probably they will do one thing, puja vacation days should complete, means by October, end of October exam should be completed. মানে
স্যার জয়ন্ত স্যার কৈ আছিলে স্যার আগষ্টৰ এন্ডিং ছেপ্টেম্বৰ ষ্টাৰ্টিং এনেকুৱা কৈ আছিলে।
হয় নেকি? এইটো
অ'
হ'বও
স্যাৰ।
পাৰে, কিন্তু মই তেনেকে ভাবিছো, কাৰণ অক্টোবৰৰ পৰা ষ্টুডেণ্ট আহি যাবতো, নতুন নেক্সট বেলেগ ষ্টুডেণ্ট, তাৰ আগত
স্যার
তহঁতক খেদাব লাগিব।
ছেপ্টেম্বৰ সেইটোৱেতো ছেপ্টেম্বৰ মাহত স্যাৰ
এইটো
হেৰি
মানে
নিউ এডমিশ্যন হ'ব বুলি ক'লে।
এডমিশ্যন কেনেকে হ'ব? ছেপ্টেম্বৰত পৰীক্ষাহে হ'ব নেকি?
নাই এনেকুৱাই স্যাৰ ক'লে আৰু কি ছেপ্টেম্বৰ মানে এডমিশ্যনো হ'ব, মানে শেষো হ'ব এক্সাম প্লাছ এডমিশ্যনো হ'ব। তাৰ মানে
অ
এডমিশ্যন হোৱাৰ মানে এক্সামটো শেষ হোৱাৰ আগতে মানে ওলাব ক'লে মোক, মানে এনেকুৱা এক্সামটো ওলাব মানে।
ওলাবই লাগিব। নতুন এডমিশ্যন লৈ ল'লে এটা বেটছ আহি যাব, তহঁতি থাকি যাবি, নহ'ব নহয়।
স্যাৰ যাবলৈ মন
এইটো
নাই।
খুব আকৌ এডমিশ্যন ল ফাৰ্ষ্ট ছেমিষ্টাৰৰ পৰা।
না না স্যার बहुत बेसी पढ़ लो।
बैक लगा लो,
পাৰ্টি প্লেন কাইলে
बैक लगा लो।
পাৰ্টা
नहीं नहीं मेरे को
अच्छा
लगा
मौका
कैसे
मिल
नहीं
गया
करना,
फिर
मेरे
से
पे हो गया, मेरे एक ही बार में हो गया।
क्या
नहीं होगा ना, तुम दिग्बय वाले